This is Coit Berenger here in the lab. Recently I've been inspired by some other YouTubers, I'm sure you know, specifically Mr. Carlson, and to do a repair of a device. So I have a cool piece of gear here. This is let's see, what is this thing? This is an OS-8U oscilloscope developed for the Navy back in the early 1950s. And I've had this sitting on a shelf for, honestly, years now. And I was going to see if I could do a restore of it. I haven't really ever restored anything, so we're going to see how this goes. Game plan is, first off, to do a physical cleanup of this. Take all the knobs, take it all apart, wash everything, get it all nice looking good. We're going to open it up, see what's inside in a little bit, and hopefully replace all of the capacitors that need to be replaced. Check resistor values, and if they're still good, we're not going to replace them. If they need to be replaced, we'll replace them. See if it works after we do that, and then maybe check the tubes, make sure everything's good there. But I think this thing only has 10 tubes. These are built pretty well, so I am hopeful that we won't have to do too much work other than that. So let's see how it goes. All right, let's see what we're going to find inside. Looks like it's pretty simple to get apart. Just unscrew the side panels. And the truth, that actually looks pretty good. Huh. These caps actually look to be in pretty good shape. Look newer than I was expecting. I wonder if somebody has come in here and already fixed this up. Well, let's get the rest apart and see what we got. I'm going to take the bottom off. I wonder if it's holding the transformer in there. Gaskets on the screws. Interesting. Wow. Look at this rubber. This is shock absorbing rubber material that this thing is screwed onto. So you can handle vibrations in a ship. I mean, it was for the, Navy or something. So I guess this would have been on a ship. Needed to withstand pretty decent vibrations. Built-in side cord. Looks pretty good. Might have to power this on in a minute. This looks pretty good inside. Looks like I can't tell, but very little damage, if any. Honestly, things look a lot newer than I was expecting. So I'm not sure if these are new capacitors. This does not look new. I don't know. West cap. Alright, so we're back here looking at this oscilloscope, and now that I look at it in a little more detail, starting to see some things which don't look quite right to me. First off, I think these are the original caps. All of these, even the yellow ones in here. Now, I actually don't have a leakage tester, so I'm probably going to have to build the one Mr. Carlson designed, which I should do anyway. So we're probably going to do that so I can actually get some empirical results for whether these caps are good or bad. But if you look way up in here, under here, I'm not sure if this shows up, the flashlight here. In the middle here, under all of these resistors, these variable resistors, is a blown up cap, one of those blown up film capacitors. And it's really hard to see it in there. It's kind of right under in there. So that's definitely going to have to be replaced. And if that's blown, I think probably all of them are going to have to be replaced. Now, we've got some metal, these electrolytic guys over here that, again, they really need to be tested, but I'm just going to probably assume they're bad. So we're probably going to pull those cans out of here, get the right values, put new good ones in there, kind of make them look like it would be normal in here. But the rest of the components look beautiful, honestly. Everything is clean in here. It looks like this was almost never used. So let's replace all the caps and see if we can get a trace, and we'll then go from there. Alright, we're going to go mobile for a second here. Hopefully it's not too shaky. Just want to show you the absolute beauty of the design of this thing. I mean, this thing comes apart in these modules. Let's see if it gets to focus there. I'm going to go up top on here, and it comes perfectly apart into the 4 pretty much separate pieces. And it looks almost new inside, other than some capacitors that have blown up. I mean, absolutely beautiful. So we're going to go in here, probably test and replace all of these caps, and hopefully get this thing running again. Hey guys, Coit again. I am in the middle of recapping the oscilloscope I've been telling you about. I wanted to show you these cans. Now, I just dremeled the bottom of this so I could put the new caps in it, and this is what's inside. I've never actually taken one of these apart, so yeah, it looks pretty nasty. Oh my god. Okay, well, there is electrolyte crusted all over there, and then wraps of foil. Interesting. Well, I'm gonna clean this out and then see if I can get, I have like 3 of these new caps, which I'm gonna try to connect them up in this and then glue it back together so it kind of looks new. So that's what we're gonna try to do. Like I said, I dremeled around the bottom. I want to use these same tie points, hopefully, and just get these new caps in this old cap case and glue it all back together. That's what I'm going to do. So, back to the recapping and repackaging of this capacitor here. I ran into a couple problems that I'm going to explain here. One being that my new capacitors actually don't quite fit into this old can. They don't quite, a little too big. So I think we're going to not do this idea, at least for this set of capacitors. And what I'm going to do is I'm going to instead mount this on the top of the base here, all neatly, so that we can still use the same terminal tie strips kind of built into this thing. I was going to do that, and then because when I pulled the capacitor apart, there's these nice little connection points that connected to the foil inside the capacitor. Well, the problem I ran into is apparently that metal is different type of metal than the actual terminal points here. These terminal points are easy to solder to. They have, a tin coating or something. Apparently these are just straight up aluminum. And on closer inspection, I can actually see where they spot welded the aluminum that goes into the capacitor and connected to the internal foil to this nickel or I don't know, whatever it is, tab or zinc tab on the top here that you actually solder to. It's like crimped down kind of in. It's probably really hard to see, but they've actually crimped it. So you can't actually solder to this, which is really annoying. So what I did was I drilled holes, 3 little holes, for these capacitor leads to go through. Hopefully I can poke them through. And then I'm going to take the capacitor leads that are solderable and wrap them around the solderable terminals on the top part. So I have no idea if this is how people mount these at all, but it made the most sense to me. So we're going to go ahead and see how well this works. Okay, here is the OS-8U oscilloscope. Pretty much completely disassembled still, but I just finished up the recapping process. I wanted to give you guys a look at that. This thing disassembles so nice, as you can see in these sub-module pieces. I'm not sure how much I can zoom in on one of these here, but I guess not much at all. But you can see all the new caps I placed here. I left a lot of these in place. You can see how I mounted this electrolytic cap. There are now modern replacements, these film capacitors, capable of the same value. So what I did was I cut the metal off of one of the backside of those capacitors, cleaned all the guts out of it, and then glued these to this metal plate. So that way, if at any point I can just unscrew the 2 screws and remove this little capacitor module. So that was the best way I could think of to mount these new guys in here. Let's see, all of the capacitors that needed to be replaced, like this blue guy is new. You can see some new caps down in there. All the back guys were replaced. You get the idea. You can see down in there, those metal cans have the new caps in them. So those guys are packed with the new capacitors. Anyway, I'm going to get the tube back in this thing, the CRT, and we're going to fire it up and see if it works. Hey guys, it's Coit Behringer again. I am back after about a week. I had to wait for parts to come in. I had to rebuild the internals of this thing, replace all of the bad capacitors, but I am finally finished. There's still a little bit of cosmetic work, but I am really itching to give this thing a try and see if we have a somewhat working oscilloscope. So I think we're ready to plug it in. Like I said, I cleaned all the outside, still have a little bit more to do. I've replaced all of the capacitors that need to be changed, and we are going to see. Now, I'm going to just plug this straight into the wall. I'm not going to use isolation transformer at the moment, mainly because I know this thing has an internal transformer and 2 fuses in line with both legs of the 120 line. So they've kind of designed it with this little extra ground pin here, so it should be pretty safe, assuming that transformer is okay. And seeing the inside internal condition of it, I am trusting that it is. But I mean, I will go with it. So here we go. So this is off. I've kind of set up the controls. So of course we have the horizontal amplifier in sweep mode right now. We have horizontal gain control here. We'll play with that. Sweep circuit, just pick a random frequency, basically just generating our frequency. We have a line selected for the sync circuit, so we should see just a line drawn on the screen. Our vertical amplifier is, we should see this line, we're not going to see anything on that yet. And then of course we have left, right, up, down positioning controls for that line on the CRT screen. And then we have a focus here, and of course our power and intensity. So, without further ado, let's see what we got. Not going to worry about that ground right now. Okay. Red light, that's a good sign. We're going to turn the intensity up. Oh! We have a dot that just went off screen. Alright, let's see if I can move the horizontal, and there's the dot. Move it down. Hopefully this is showing up on the camera. We have a trace. All right, it's not aligned, so that means horizontal gain needs to be increased. I think. Boom! There we go. Ah, it's a little crooked. Okay. Focus. Hopefully the camera's catching all of this. Got a line. It works. I don't hear anything. I don't smell any smoke. Pretty cool. Now, the line is crooked, so what we're going to have to do, Mr. Carlson goes over this in a very good video of his, but basically we have to align the CRT mechanically to get this trace to be perfectly even in line mode. So I'm going to have to open this back up and actually twist the CRT carefully until that, and then put it all back together, or reseal the box up, and then redo this, and keep doing that over and over again until I get that line in line mode perfectly horizontal. And that's not too hard, probably take a few minutes. But I want to see if I send the signal into this vertical input, if this thing actually works as an oscilloscope. So up here I've got a signal generator, so we're going to have to go ahead and turn that on. And I'm literally going to take an oscilloscope probe right here. So I've got an oscilloscope probe, which I'm going to hook to this BNC jack on the vertical input. And I'm going to set the vertical amplifier into just 1, gain of 1, or attenuation 1, AC. And then the vertical gain is just kind of low right now. And then we're going to hook a BNC jack with 2 alligator clips up to the 2-volt peak-to-peak output of this signal generator. And I don't even know what this is set on. It's just set on a sine wave at some frequency. So let's see what we got. Hook the grounds together. Should be pretty safe to do all of this. Oh, hello. Hello, sine wave. So I just increased vertical gain. Looks like we have a signal. Ooh, okay, so now I'm controlling the sweep circuit to try to find... there we go. Sync circuit had to be on internal. We now have a sine wave. There we go. Intensity up, focus a bit. Hey, we have a working oscilloscope. And if I change the frequency up top here, looks pretty damn good. That is cool. So I don't know if you can see this in the camera. Actually, let me see if I can focus in on this a little bit. But it works. All right, I just readjusted the camera onto the scope so you guys can see. This thing's working beautifully. I'm not really sure what locking does. It looks like that's how you kind of trigger. Can it do a square wave? Oh, damn, look at that. Does a square wave. Let's change the frequency a little bit and get more. No, that's the wrong thing. It can do a square wave. All right, so I successfully aligned the cathode ray tube, so it's pretty much horizontal mechanically in the case. As you can see, I'm still putting a signal into it from the signal generator, and everything appears to be working almost perfectly. The next steps for something like this are really just cleaning up some cosmetic stuff, maybe doing a slightly more detailed alignment and testing of some internal parts, but I need to do some research on what exactly I need to do that. And luckily the manual for this, and pretty much all the documentation for this, is online, and you can just Google for the schematic. As you can see on the front here, somebody has marred the kind of this panel here. Maybe there was a sticker or something here before. I'm not real sure, but it doesn't look very good. I actually think I might make a proper label for this oscilloscope to put over that, so you kind of can't tell, and it looks all nice. Everything else looks actually really good. I'll take some close-up shots and kind of scroll through them probably during this video so you can see some of the more close-up details. Unfortunately, my camera's not super great, so I'm kind of working with what I got. Other than that, I think I may actually turn this into a curve tracer, a la Mr. Carlson's design, but that may take a circuit board redesign or some modification, or mounting it externally on the back or something, because there is not a lot of space in this oscilloscope at all. They have packed this very compact. I mean, it's beautiful the way it's constructed, but it is pretty tight in here. So kind of just to finish up, you can see these are kind of my pile of capacitors that I replaced. I don't have the electrolytics here, but this was the most interesting one. Hopefully this shows up. This capacitor had actually exploded inside this oscilloscope. So I don't know if someone put too much power onto, this was the DC blocking capacitor connected to this AC input that I'm sending a signal in right now. So somebody maybe overloaded that and it kind of blew up. I'm not real sure, but kind of interesting. I've never seen the kind of some internal foil has come out, almost like it literally made a little jet. Anyway, kind of interesting. So this takes a long time to restore this stuff. This is my first real restoration project, and I have to say, it was a lot of work. So I'm impressed by the people who do this all the time, but hopefully I will be doing more of these and collect up a cool set of working test gear using all of this really cool old equipment. So anyway, thanks for watching.